Okay, here we're in chapter 2 on linear functions, and this is section 2.3. We're going to model with linear functions. So we need to identify steps to model and actually solve the problems with linear functions. So first we're going to identify the changing quantities, and then we're going to define descriptive variables to represent those quantities. So we're going to probably be given a word problem, and then we have to define the variables and things like that. And so when appropriate, we should probably sketch a picture, define a coordinate system, all those things to get everything so we know what's going on with just the problem itself. And what we need to do is carefully read the problem to identify the important information. Then we look for information that provides values for the variables or values for the parts of the functional model, such as a slope or initial value. And we carefully read the problem to determine what we're trying to find or identify or solve for and interpret. So sometimes you might actually be asking for an area, another time you might be asking for a length. And so you have to know what are you actually trying to look for here. And then we want to identify a solution pathway from the provided information to what we're trying to find. So this is going to often involve checking and tracking units, building a table, or even finding formula for the function being used to model the problem. And when needed, we need to write a formula for the function. Then we solve or evaluate the function using that formula. And then we reflect on whether your answer is reasonable for the given situation and whether it makes sense mathematically. Sometimes you might come up and you work everything and all of a sudden you have a length of -22. Does that make sense? Not really, because you shouldn't have a negative length. So you know you've done something wrong along the way somewhere. And then after that, we need to clearly convey our results using the appropriate units and answer in full sentences when necessary. So that's kind of the steps, but kind of in a more general sense, using the given input and output, we're going to build a model. So we're going to identify our input and output values. We're going to convert that data to two coordinate pairs, x, y pairs. We'll find a slope, then we're going to write the linear model. And then we'll use that model to make a prediction by evaluating the function at a given x value, and then use the model to identify an x value that results in a given y value. And then we're going to answer the question posed. So this is kind of more the general for linear. The other one was more for any kind of application word problem that we could be looking at possible. So let's do an example here. So say we have a company and they sell donuts. They incur a fixed cost of $25,000. That includes the rent, insurance, and other expenses. Then it also costs them 25 cents to produce each donut. Now what they want us to do is A, write a linear model to represent the cost C of the company as a function of X. So that means they want us to find some C of X as the function X, the number of donuts produced. And so here, X equals number of donuts produced. Okay, so that's what we're looking for. And then in B, we want to find and interpret the y-intercept. Well, first let's write our cost function. So we want to write something function C of X. Well, what do we know? Well, we know we have a fixed cost of 25,000, and we're add to that 25 cents to produce each donut. So if we write it in an equation form, remember it's y equals mx plus b. So whatever we're taking times our x, in this case x is the number of donuts, well, let's put that first, and then we'll put our plus b here, which is going to be kind of like our fixed cost. And so we're going to have 25 cents per donut, so it's going to be 0.25x plus our fixed cost of 25,000. And so that then would be our actual function that we're going to use. And again, this is cost per donut. And we'll just put D for donut. And then this is the number of D. And then this is going to be our fixed cost. Okay, so that's everything we were given in our initial two sentences here, and we included it all in our cost function. Now it says find and interpret the y-intercept. Well, what does that mean? Well, that means we're going to plug in x is equal to 0. And so y-intercept is going to be x equals 0. And so we're going to have c of 0 equals 0.25 times 0 plus 25,000. Well, that is 0. So c of 0 is 25,000. So what does that mean? If 0 donuts are produced, so if 0 donuts produced, we still have $25,000 in expenses. Okay, so that's what it's mainly telling us. It's our intercept, basically our B, our y-intercept, and it's saying that we still have that no matter if we produce 0 donuts or not. Okay, and so that's going to still have that $25,000 in fixed costs. Well, let's do another one. Here it says a city's population has been growing linearly. In 2008, the population was 28,200. By 2012, the population was 36,800. Now, assume this trend continues. So that means we're assuming every year past 2012, it's just going to keep doing the same thing as far as moving up and up and up every year, the same amount or the same amount per period of time. And what they want us to do is we want to find the population in 2014, and then we want to identify the year in which the population will reach 54,000. So that all means that we have to actually figure out an equation for the line. And so what we have to do is think about, okay, well, 2008, that's going to be time equals 0. And then 2012, that's going to be time is equal to what? Well, if we add 4 to that, that's going to give us 2012. So here we have time is 0, and here the population is 28,200, and here the population after 4 years, it's 36,800. Okay, so if we write that as an ordered pair, like we kind of mentioned in the one item, that's going to be 0, 28, 200, and that's going to be 4, 36, 800. So we have 2 points. Well, what do 2 points give us? Well, 2 points, we can find the slope of a line, plus we can find the equation of the line too. And so remember, slope is going to be the change in y over the change in x. Okay. So the change in y, so I'm going to take our number 2 minus number 1. So that's going to be 36,800 minus 28,200 over, then we have 4 minus 0. And so that's going to give us, now if we subtract those, we can divide by 4. We can do that on a calculator if we want to do that. We've got a calculator here. And so we have, let's go 36,800 minus 28,200 divided by, and 4 minus 0 is just 4, so we can just do that. And we have 2150. All right, so 2150 then is going to be our slope. All right, well, what's our intercept? Well, our intercept is this point here, and so our equation of our line, now let's say, since we're doing a population, let's say P of X, where X is going to be the year, is going to be equal to our slope, 2150, times, depending on what year it is, X, and then plus our initial intercept of 28,200. Okay, so here X is equal to the year after 2008. Okay, so that's going to be an equation we need. And now they say, well, let's predict the population in 2014. Well, how many years after 2008 is 2014? Well, that's 6. So 2014 is t equals 6, or, you know, if we want to do x equals 6 is what we just plugged in here, then we'll have p of 6 equals 2150 times 6 plus 28,200. And so if we go back over to our calculator here, we're going to have the 2150 times our 6 years plus our 28,200. And that gives us 41,100 people at that point in time in 2014. So that's going to give us 41,100 people in 2014. And again, this is assuming that trend continues past the 2012. All right, so that's what we wanted for the first part in part A. So that is our first answer. Now the next one, it says identify the year in which the population will reach 54,000. Well, then we're just saying, well, that's the population, so 54,000 equals 2150x plus 28,200. So we'll subtract 28,200. And so then we'll get 25,800, it looks like, equals 2150x. Now we'll divide by 2150. And so then x is going to be, and if we do that over here in our calculator, that's going to be, and we can do, what was it, 25,800 divided by, and it was 2150. And that's 12. So in 12 years. But it asks what year. So 12 years after 2008. So 12 plus 2008. So that's going to get it the year 2020. Okay, so that's when our population will hit that 54,000. And again, we have to assume that trend continues. Otherwise, you know, it might be going up and then all of a sudden it just drops. We don't know why, maybe whatever it is. And so we have to assume that it continues to go up no matter what, and it doesn't do that dropping off. All right. So the next thing here, we want to use a diagram to model a problem, okay? So when we do that, we're going to have some kind of problem. We might end up having a picture we're going to have to draw. The last couple, we didn't have to draw a picture, but maybe you have to draw a picture to understand what the problem says. With triangles, you might use Pythagorean theorem. Rectangles, probably going to need lengths and widths to solve the problem. Every kind of problem is going to be different. And so let's first look at this one here where we have find the area of a triangle. So this one, we're not using Pythagorean theorem, but remember, area of a triangle is 1/2 base times our height. So that's what we're going to use for our equation here, but we're going to have a lot of other stuff to do first, I think. Bounded by the x-axis, the line f of x equals 12 minus 1/3 x, and the line perpendicular to f of x that passes through the origin. All right, so what all does this mean? Well, let's first rewrite this as f of x equals a minus 1/3 x plus 12. So now that looks like more of the familiar y equals mx plus b. So we know our intercept's at 12, so it'll be 0, 12. And then we're going to go down 1, right 3, down 1, right 3 until we get all the way down to the bottom. Well, what is our intercept going to be when we hit that x-axis? Well, that's going to be when y is equal to 0. So here we can say we have 1 point, 0, 12. That's going to be where it hits the y-axis. And now what we want to find out is when is 0 equal to negative 1/3 x plus 12. Because just to kind of get a picture, we need to know all the points to draw and everything. And so we'll subtract 12, and we get a negative 12 equals negative 1/3 x. So we're going to multiply by negative 3 to get rid of that. Multiply this by negative 3. So x equals 36. And so our two intercepts, the x and y intercept, are going to be 0, 12, and 36, 0. Okay, just from the given equation here. Now we're also going to have a line perpendicular to this one that passes through the origin. Okay, well, we know the slope here, so m1 for our original is negative 1/3. m2, what do we know about that? For a perpendicular line, it's going to be negative the reciprocal of the first one. So if we do that, it's negative 1 over negative 1/3. So we multiply by negative 3 over 1, multiply by negative 3 over 1. So our denominator's gone. Negative times negative is positive. So m2 is equal to a 3. Okay. Now, when it passes through the origin, what does that tell us about the intercept for the y value? Because this is going to be our intercept. Well, the origin is 0, 0. And so we can get our second equation. So this is our first equation. Our second equation is going to be f of x equals, well, we know our slope is 3 times our x plus 0. But usually we don't add plus 0, so we'll just leave that as our second equation. Okay. And so now what we need to do is draw a picture. So I'm bad at drawing pictures with lines, and so I've drawn that here. And so this first one here, the red, that's going to be our first one, which is y equals negative 1/3 x, and then that's the plus the 12. This is the y equals 3x. And what else did it say in our problem? It's bounded by the x-axis. So our triangle we're really looking at, now let's see if I have a highlighter here. Our triangle is going to be that all the way over there, and then all the way back up here. So that's our triangle. So what do we need to know from that? Well, I've just drawn this vertical line at this point here. So what we need to do is we need to find out what this point is, because if we know that point, that's going to give us, because we're going to need to know what is that point, because we'll need our x and we'll need our y. Not really necessarily the y, but we'll need our x, because if we know our x, that means we'll know what our distance is here. And then our y is going to be actually necessary because we need to have our height, and that's going to be whatever that y is. So x is going to give us what we need to get to that y. So we really do need that. And so our height will be part of it, because remember, we're looking for area is equal to 1/2 base times height. Well, we know the base, that's right here, all the way over here. We know it crosses here at 36 because that was one of the points, 0, or actually 36, 0, sorry. 36, 0. This was a point here from getting that line. That was 0, 12. And so this is our next thing we need to do. So let's go back and figure out if we can get to that point where we know what that height is or what that x value is. Okay, well, I guess if we think about it, when that line intersects that line, if we set those two equal, that should give us that point there. And so if we set those two lines equal, 1 and 2, so we have a negative 1/3 x plus 12, and we set that equal to the second one, which is just 3x, we can solve for x, and from that, then we can solve for y. All right, so what are we going to do here? Well, let's add 1/3 x to both sides. So 12 is equal to, and 3 and 1/3, so that's going to be 10/3. Oops, 3, and that's an x here. So 10/3 x. Now we want to solve for x, so multiply by 3 over 10, multiply by 3 over 10. Now, 2 will go into 10, 5, 2 will go into here, 6, so we have 18 over 5 is what x is. Okay, so that's our x part of the intercept here, where the 2 cross, 18 over 5. Now, from that, can we get the y? Well, if we just take 3 times that, so 18 over 5, and then times 3 over 1, because we can change it to that, that's going to be what y is equal to. And so what is that going to be equal to? 3 times that looks like 54 over 5. So that's 54 over 5. Well, that is height. Remember, that's where the height is. So that's 54 over 5. So now do we have everything we need to find area? Well, area is 1/2 base. So area is 1/2 times the base, which we said was 36, times our height, which we just found is 54 over 5. And so now what we have to do is we have to kind of multiply that all out. Now the question is, do we want to leave it as a decimal, or do we want to leave it as fractions? It really doesn't matter too much, and I don't think this problem actually said. So let's multiply it here. So we're going to have, what was it, 0.5 half times 36 times 54 divided by 5, and we get 194.4. So this is going to be 194.4, and it's going to be something squared. And they never actually said what any of the units are, and so we'll say this is units squared because we don't know what those units are. And so the area is equal to the area of the region given. And that was given by this line, the base x-axis, and then the y equals 3x. So everything within that yellow triangle, that's the area of the region given. Okay, and so that's one where we had to go through and, they gave us the first function. Then we found our points to kind of plot those on the thing. So we plotted that point, we plotted that point, and we could draw a line between them. And then after that, we could say, okay, well, we know the slope. So we took and found the reciprocal of it and got the second slope. We knew it went through the origin, so we got our second line, and we could draw that one. And then we kind of drew a vertical line through that. We didn't know exactly where it was at. And from there, we could actually find our x value by setting the two equations equal and solving for x, and then plugging that into, and again, it doesn't matter, you could plug it into either equation, and we solve for y. And then we just used our area of the triangle formula to find the 194.4 units squared. All right. How about the next one? It's going to be similar. They're going to ask us to find the area of a parallelogram. And so parallelogram, what is the area of that? Well, area of a parallelogram is just base times our height. So that's all we need to have here. And this one says it's the area of a parallelogram bounded by the x-axis. So again, it's all the way down at the bottom, just this x-axis. Passes through the line g of x equals 2, so y equals 2, so that's the purple line. The line f of x equals 3x, and so again, I did all this, and so I didn't have to hand draw it in. It's going to be too hard to do that, so that would be that line. And then we want the line parallel to this, but through the 0.61. So we moved it over, and here's the 0.61, and it's parallel. So basically, we're going to go up 3, right 1, up 3, right 1. And that would be our point here. And now what we need to do is we have to figure out what is our height. Well, our height, pretty easy here. They told us that. So height is equal to 2. So that part we have down. The part now we have to find is what is our base. So from 0 to what is that value here. All right. So what are we going to do? Well, basically, we know that this was y equals 3x. We know then that this point was 6, 1. And so since those are parallel lines, m1 equals m2 is equal to 3 because we knew the slope here. And now we use our point slope formula. So we can use this point, y minus, and our y value is 1, equals slope, which we said is the same, times x. Now here we have minus 6. Now we just solve. So we add 1, and we get y equals. Now we have to distribute. That's going to be 3x minus 18 plus 1, or y equals 3x minus 17. So that's the slope of that line. Well, now what do we have to do? Well, now we have to find what is that point, because that's going to tell us, if we know that point, we'll know how our base is, how big our base is, because we can just go from 0 to whatever that is, and that will give us the base. Okay, so that means we have to set this equation equal to 0 and solve for x. So do I have an extra page here? Yeah, so let's say y equals, and that was 3x minus 17, and we want y equal to be 0, so 0 equals 3x minus 17. So we'll add 17 to both sides. So 17 equals 3x, divide by 3. And so x equals 17 over 3. All right, so that means that that point then is at 17 over 3, comma 0. And so that means the base is 17 over 3. And again, we don't know the units. It's it's not a given, so we don't know what that is. And so what we can do now is we can find the area is equal to the base, which we just said was 17 over 3, and then times our height, which we said was 2. And so area is equal to 34 over 3 units squared. And this time I left it as a fraction. We could go ahead and divide that if we wanted to, but you know, it's easy just to do it in your head and you don't actually have to do anything. And so the area of that parallelogram based on the lines given is equal to 34/3 units squared. Okay, so let's stop there and then I'll continue on with the part 2.